Hi, everyone. Thanks, Derek. So it's great to be right after Pete from Google. So he talked a lot about bringing deep learning into different embedded devices and tuning the precision of the deep neural networks very low into 8-bit or maybe lower. And in this presentation, we'll try to show how we can use such frameworks and such neural networks and actually deploy them in products in the near future in very, very low power and for mass production for devices that everybody can use, basically camera-enabled technology. So I'll start quickly for a very quick introduction to CEVA, for those of you who are not familiar with the company. So CEVA has been in the market of licensing IP for over 25 years now. We are a public company listed on the NASDAQ, and our focus is basically licensing low-power signal processing to chip providers for embedded devices. So we have essentially four product lines in the company. One which I'll talk about in today's presentation is focused on imaging and computer vision. Second product line that we have relates to anything that runs audio, voice, sensor fusion, very, very low power, always-on technology. So as an example, we are inside the Samsung Gear S2 smartwatch, doing the voice activation all the time on, released just a couple of months ago. Third product line that we have in the company is for connectivity. So we license IP, for example, for Wi-Fi and Bluetooth. So some products in the market using our Bluetooth technology, for example, the Nest thermostat and a Xiaomi wristband, which is very, very low cost. I think the market price is about $12 in China. A fourth product line that we have, which probably is our most successful to date, relates to communications, so communication standards such as baseband for 3G, for LTE, and so on. We have very good market share, so about 30% market share for baseband and example products. So we're inside basically most of the Samsung devices and many others. So for example, the Samsung Exynos application processor is using our IP inside for the baseband communication. So to date, CEVA powered devices have shipped in over 7 billion devices, and we have an annual rate of about 1 billion devices, so a lot of devices out there using our technology, a lot around different consumer mass production. And our hope is to get the vision products, the deep learning products out there in the market very soon as well, and we're on our way to do that. So what we'll talk about today is how CEVA helps to take these neural networks from offline implementations after trainings that were done and take them quickly and efficiently into mass production products. We focus mostly on camera devices, and we enable that by a very robust framework, software framework running and optimized for our vision processor, and I'll explain later. So essentially, we automatically convert pre-trained networks for neural networks to the real time very quickly, and we are able to achieve a very good performance. So if we compare our platform or networks running on our platform compared to mobile GPUs, we get there much more efficiently in terms of power, and we are able to work on optimizations both on the memory bandwidth, and of course we get there very efficiently as well. So I'll give you a little bit background. I'll keep it brief because I think most of the presentations here gave background already on deep learning and embedded space. Tell you a little bit about what CEVA's neural network framework includes. Explain how the developer, one who already has a network, how he takes this framework and ports it onto the embedded platform quickly. And then give an example of AlexNet, which we have and utilize on our processor, and summarize.